back. Last time we went ahead and talked about sequences. In this video, we're going to be extending that to talk about series. So series is simply when we take the terms of a sequence and we add them all together. Okay. So here, let's go and take a look. This is series, right? And just to define this, a series is a summation of the terms in a sequence. Okay, and there's two different types of series. There are finite series and there are infinite series. We're going to save infinite series for your later math classes. We're just going to talk about finite series. So we're going to focus here on finite, which means it has just so many terms. Okay, so here this word sum tells me the operation is going to be addition. Okay, so here let's go ahead and take a look at a series. Right. So if I have the series just 1, 4, 7, 10, 13, right? Now you'll notice here, this one does not have an ellipses at the end, right? This series stops, all right? I'm sorry, this sequence stops, okay? It only has 5 terms, right? What I can do is I can define a various number of series, right? So remember that this is a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5, right? So I can define S1. S1 is simply going to be A1. So for this one, S1 is equal to 1, because that's the first term in my series, all right? Now here, S2 is going to equal A1 plus A2. So in this case, S2 is equal to 1 plus 4, because A1, A2. So S2 is equal to 5, right? And I can keep going. I can go ahead and figure out what is S3. Right, now S3 is going to equal A1 plus A2 plus A3. So that's going to equal, if we think about this, there's a couple of ways to do this. A1 plus A2, well, that's S2. So it's kind of S2 plus A3. So we kind of define it recursively, right, based upon the previous term, right? So S2 plus A3 is going to simply be 5 plus 7, which is 12, right? And we can keep doing this. We can actually figure out what S5 is here, right? So S5 is just if I were to add all of them together. So I've got 1 plus 4 is 5, plus 7 is 12, plus 10 is 22, plus 13 is 35. So S5 is 35. Now here, this is pretty good because this is a pretty small series, and I want to add them together. It's just 5 numbers. It's a piece of cake. But it helps sometimes if we can get an explicit formula going, right? So what we're going to do is we're going to see if we can figure out an explicit formula. So what we're going to do is we're going to take S5, right, and we're going to go ahead and we're going to add S5, right? So S5 is really just all of these numbers added together. So it's 1 plus 4 plus 7 plus 10 plus 13. Now for S5, it's the same numbers, but what I'm going to do is I'm going to add them backwards. And kind of watch what happens here, right? It's kind of neat. I get here 13. Right, plus 10, plus 7, plus 4, plus 13. Okay. Now over on the left, what am I going to get here? Well, S5 plus S5 is 2S5. Now watch what happens with all these sums. 1 plus 13 is, well, it's 14. 4 plus 10 is 14. 7 and 7, 14, 10 and 4, 14, 13 and 13. I'm sorry, I messed that up. It should be 13 and 1. 14. Okay? So look what happens here. 2 S5s is going to be 5 14s. So another way to write that is 2 S5 is equal to 5 times 14. Now if I want to get S5 by itself, I can simply divide by 2. Right? And so I end up with S5 is equal to 5 over 2. Now this 14, right, we're going to replace this 14 with one of the sums we got up top. Now you'll notice here, this 1 is a sub 1, this 13 is a sub 5. So here, this is 1 plus 13. Now we can generalize this, right? So let's take a look at what we did here. In general, the sum of all the numbers in a sequence, 1 through n, will equal this number n, right, because the 5's match, times 1, which was the first term, right, we saw up there, so a sub 1, plus 13, which was the last term, or the fifth term, so plus a sub n, divided by 2. Okay. So this is our formula if we want to go ahead and add up the numbers in a sequence. Okay. So let me just show you again what this looks like now in a problem. Okay. So for a problem, I want you to go ahead. We're going to take a look at the sequence, which is 2, 6, 10, 14, 18, and 22. Right. And again, we can see this is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6. Okay. So if I wanted you to figure out, hey, what is s sub 6, right? It's simply going to be 6, right, because that's n, times the first term, which is 2, plus the last term, which is 22, the whole thing cut in half. And we can simplify this any number of ways. 2 plus 22 is 24. 24 divided by 2 is 12. 12 times 6 is 72. Right? So I know that these numbers are all going to add up to 72. You can go ahead and check this, right? 2 plus 6 is 8. 8 and 10 is 18. 18 and 14 is 32. 32 and 18 is 50. 50 and 22, 72. All right, so it's a neat little shortcut that really helps you when you have to add all the numbers in a series. All right, so if you're taking a sequence and you're adding them all together to make a series, this is a great shortcut. Okay, so that's the first thing we should know about series is this formula, which is great for grabbing the nth sum. All right. Now the next thing we're going to take a look at is a new notation. Okay, so this is what's called sigma notation. Okay, sigma is this right here, right? Maybe you've come across this button on your calculator, you've seen a formula before, but this is sigma, right? And it basically implies a series, right? And so it tells us we're looking at a series where we're going to add all the numbers. So series, add all the numbers. Okay? So here, just to show you what this kind of looks like, right? When we write this formula, right, you're going to have sigma of some explicit formula that shows you the terms in the sequence. So here I'm going to do sigma of 2i minus 6. And here I just represents our index, right? It's a placeholder. And this is going to tell me that I'm going to go from I equals 1, so the first term, all the way up to the 9th term, right? So if I want to expand this out, what I'm going to do is I'm going to go ahead and plug 1 in here, right? So if I plug 1 in here, 2 times 1 is 2, 2 times 1 is 2, minus 6 is negative 4. Now I bump my index up to 2. Now I'm going to plug 2 in here. 2 times 2 is 4, minus 6 is negative 2. Now I'm going to make this 3. 2 times 3 is 6, minus 6 is 0. Now I'm going to make it 4. 2 times 4 is 8. 8 minus 6 is 2, so plus 2. All right. 5. 2 times 5 is 10, minus 6 is 4. 4. All right. Plus, now we'll go ahead and go with 6. 2 times 6 is 12. 12 minus 6 is 6. Plus, keep on going. Now, just so we're clear here, right? I've done a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6. So I still got to do a sub 7, a sub 8, and I'm running out of room, but a sub 9 should end up here, right? So now here, if I plug in 7, 2 times 7 is 14. 14 minus 6 is 8. I'm going to plug in 8. 2 times 8 is 16, minus 6 is 10. And I'll plug in 9. 2 times 9 is 18. 18 minus 6 is 12. Now I stopped at a sub 9 right here because my top number over here was 9, right? So that's how I knew stop there, okay? And now I can just add these all together. But you can see that this was painstaking. This was absolutely awful. Nobody wanted to do this, okay? So what I could have done to make this a lot easier is I could have said, oh, well, let's figure out what the first term is, right? Because I know S sub 9 here is going to equal whatever, 9 times my first term, right? So I plug in 1, 2 times 1, 2 minus 6 is negative 4, plus my last term, just plug in the 9. 2 times 9 is 18, 18 minus 6 is 12, and then the whole thing over 2, all right? And I can go ahead and simplify that. Negative 4 plus 12 is 8, 8 divided by 2 is 4, 4 times 9 is 36. And so I would get 36 for my answer. So again, that formula is a real time saver. What's more important here is I just want to show you what sigma notation means. So sigma, this condensed form here, is the same thing as this long expanded out addition problem over here. They are equivalent, okay? And you can double check this. Negative 4 and negative 2 is negative 6. Negative 6 and positive 2 is negative 4. And positive 4 is 0. And then 6 plus 8 is 14. 14 and 10 is 24. 24 and 12 is 36. All right? So again, this is always the quicker way to go, okay? So let's take a look and apply this to a problem. We're going to have to apply a couple different things that we've had to do already. All right, so here, our first example, we're going to be asked to find what is the sum of the sequence that is 2 plus 9 plus 16 plus ... all the way up to 79. Whew, so what does that equal? All right, so this presents a real challenge for us because when we look at this, we don't actually know how many terms are here in this sequence. All right. So what we're going to do first is we're going to figure out what the common difference is here, right? So again, I told you to always be an arithmetic sequence. So what am I adding to get from 2 to 9, right? Well, if I take a look here to get from 2 to 9, I'm adding 7, right? 9 to 16, adding 7, right? So I can see here that my difference is plus 7, okay? Now that I know the difference, I can actually figure out which term this is in the sequence, right? So I don't know exactly what it is. But I know that 79 is going to equal, right, whatever my first term is, 2 plus, and then it's going to be my difference, 7 times n minus 1, right? And that's just my formula, right? A sub n equals a sub 1 plus d times n minus 1. Now what I want to do here is I want to solve this for n. I want to figure out how many terms are being added together. Okay, so if I do that, I can see here, I'll subtract 2 from each side. Actually, you know what I'll do is I'll distribute this 7. So I get 2 plus 7n minus 7, right? So I distributed the 7. All right. Now I'm going to combine like terms, right? 2 minus 7 is negative 5. So I get 7n minus 5. So 79 equals 7n minus 5. All right. We'll go ahead, we'll add 5 to each side. We get 84 equals 7n. We'll divide each side by 7, and we find that n equals 12. So I know up here in this summation here, right, this series, there are 12 terms. There are 12 numbers that need to be added together. So I can go ahead and I can write my explicit formula. So what's my explicit formula going to look like? Well, my explicit formula, I'm going to go ahead and put my sigma here, right? It's going to run from n equals 1 all the way up to n equals 12. And I already know my explicit formula, right? My explicit formula, a sub n, is equal to a sub 1, so 2, plus, right? And then here, we kind of have this idea of 7n, I'm sorry, there it is. How embarrassing. 7n minus 5. All right, so we already have our explicit formula. It's the 7n minus 5 here. Right, and the way I got that was essentially, so the way I got that here was essentially just going back to this formula, right? And what I did here was said a sub n equals 2 plus 7 times n minus 1. And then we essentially just went ahead and simplified that, okay? 7n minus 5. So now I can use my shortcut, right? I know that I want the 12 terms. So s sub 12 is going to equal 12 times the first term in my sequence. What's the first term? 2. What's the last term? 79 divided by 2. Okay. Now if we go ahead and do this, 2 plus 79 is 81. Now you'll notice I've been doing these two numbers divided by this, but this time I got an odd number. So I'll do 12 divided by 2 is 6. 6 times 81 is 246. Okay. So if I were to add those all together, I would get 246. All right. Does that make sense? Hopefully it does. Excuse me. So again, we figured out how many terms there were. We went ahead, we wrote our sigma notation. We probably could have skipped that step and gone straight to this because we knew it was S sub 12 equals 12 numbers, the first term, the last term divided by 2. All right. So I could have skipped this step here. All right. So let's go ahead and apply this to a word problem. Quick word problem, right? So you're building stairs. When you're building stairs, the top step consists of 15 bricks. All right, so there's 15 bricks across the top step. Okay. Now across the bottom step, there's going to be, I don't know how many bricks. Sorry, there's 17 bricks on the next one. So then 15 bricks, then 17 bricks, then 19 bricks. Right. So as these steps go down, right, you've got the top row, then you've got the next row, right, which is one wider on either side. Then you got the next one wider on either side, right? And it keeps on going like this. And what we're told is that there's 16 stairs. So there's 16 stairs. How many of those bricks am I going to need to make the top rows each time? So kind of think of like building a pyramid. It could be like stacking cans for a grocery display too, right? So here's 16 stairs. All right. So let's take a look at how we would do this. All right. We want to find sub 16. Okay. So sum 16 we know is going to equal 16 times the first one, right, which is 15, plus the last one divided by 2. So I need to figure out how many are going to be in that last row. So I need to come up with an explicit formula for what's happening here, right? So my explicit formula, right, a sub n equals a sub 1 plus plus d times n minus 1, okay? So here, a sub 1 is 15. I can see the difference each time is I'm adding 2, so plus 2, right? And then for a sub 16, 16 minus 1. So a sub 16 will equal 15 plus 16 minus 1 is 15 times 2 is 30. So a sub 16 will equal, sorry, I didn't realize I wasn't showing that, will equal 45. So I plug that number in here. Okay. 15 plus 45 is 60. 60 divided by 2 is 30. 30 times 16 is 480. So there will be 480 bricks. Okay. Does that make sense? Hopefully it does. If you have any questions, please go ahead and email me. The quizzes should be pretty straightforward this week. You guys will do well. All right, take care.